Hello, in this video, I will explain the key concepts of sound power, sound intensity, and the inverse square law. Sound power refers to the total acoustic energy produced each second by a given source. This is a basic property of any device capable of producing sound. However, it does not change based on distance between an observer and the distance producing the sound. Unlike sound pressure or sound intensity, the sound power measurement remains constant since it describes the device generating the sound rather than the environment surrounding the device. Sound power is usually expressed in watts and will remain unchanged regardless of distance, reflection, and/or even atmospheric conditions. In our experiment, the phone speaker produced a continuous tune with a fixed sound power output. Even though the measured sound level decreased with increasing distance from the speaker, the total power produced by the phone continued to be constant. Therefore, the expected power readings from the phone when measured at various distances should be similar, with the only differences being due to errors in measurement and/or other environmental conditions. Sound intensity, however, is different from sound power. In a specified location in space, sound intensity is defined as the sound power that passes through the area for 1 square meter of surface area at that location. Sound intensity indicates how much acoustic energy is actually flowing through a surface, and it is affected by both the source of sound and the environment surrounding the source. In contrast to sound power, sound intensity varies with distance because the same sound energy occupy a larger area as it is radiates away from the sound source to the point of measurement. In addition, sound intensity is also affected by reflection of sound waves, sound absorption, and sound wave interference, which can increase or decrease the amount of acoustic energy delivered to a specific location. A characteristic of sound intensity is that it is a vector quantity in that it has both a specified magnitude and direction. Sound intensity is also related to sound pressure. However, there are two different quantities. Sound pressure provides a measure of degree of compression of the air molecules in the vicinity of the measurement point, while sound intensity quantifies how much energy is being transferred by sound waves to the measurement point at the same location. Intensity is also related to the decibel scale through the following formula. This formula allowed us to convert our measured decibel values into intensity values for each distance. As the intensity of sound is inversely proportional to the distance from a point source according to the inverse square law, when the acoustic power radiates through open space, it takes up an increased surface area because the surface area of a sphere increases with the square of the distance from the center of the sphere. Thus, when the distance is doubled, the surface area will quadruple. Therefore, at that point in time, the intensity of the sound signal at that location will be equal to 1/4 of its original intensity. Through the examination of this relationship, it is clear that sound intensity decreases due to geometrical spreading and not due to the loss of power from the source. The inverse square law holds true under ideal conditions of a free field and is subject to variation in not ideal conditions caused by reflections, absorption, and interference of sound waves. The results of the experiment supported the inverse square law by producing a more pronounced decrease in intensity at points farther from the phone speaker, particularly when measured outdoors, because of the absence of interference from structures or objects between speaker and listener. The references used in this lab provided the theoretical basis for interpreting our results. LibreText and OpenStack supplied equations for converting decibels to intensity, while HBQ World and Impulsion Acoustic clarified the differences between sound power and sound pressure. Hyperphysics and Neil Hozman illustrated the inverse square law and how intensity decreases with distance. Additional scientific papers supported how temperatures, humidity, and room proportion affect sound, complementing our experimental measurements. So, to summarize, sound power refers to how much energy is released from a sound source. Sound intensity refers to how much power is being produced per unit of area, And the inverse square law explains how intensity decreases with distance. All calculation and references can be found in the PDF located in the References section. Thank you for watching.